So what we're going to do today is we're going to kind of continue on talking about, or pick up kind of where we left off last time. So last time we talked about like the section 1.8 stuff, where we talked about like transformations of functions, right? What we're going to do today is we're going to define the sine and cosine function, and then talk about the attributes of those functions and think about them through the same lens of it as a function transformation. And we're going to kind of culminate in figuring out how to graph these things. Cool? Again, it'll be like, I don't know, hour tops of me, and then you guys will have time to work. So what I'm going to do is we're going to first start by figuring out what the sine function looks like. So what I'm going to do to plot the sine function, the x-axis is going to be the angle measure, and the y-axis is going to be the output from sine of that angle. So when I plot points, it's going to be an angle measure, comma, sine of that angle. Everybody's okay with that plan? So to do that, I'm just going to use the unit circle to do this. There is one question, though, and the question should be, well, the angle measures that I'm using, do I want to do this in radians or degrees? The answer, the choice we're going to choose, probably unfortunate to you guys, is radians. Now the reason is, if 2 pi is like 1 full rotation around the unit circle, right? As a decimal, 2 pi is like 6 point something. So that's like 6 tick marks on a number line, as opposed to 360 degrees, which is 360 tick marks, which is just like annoying, right? That's why the convention is to use radians, because the scale is just nicer to kind of deal with, because it's shorter. Everybody's okay with that? Okay. All right, so what we're going to do is we're going to draw the graph, or plot points for the graph of sine function. So the x-coordinates are just going to be the angle measures in radians as we work around the unit circle. So we'll start here at 0 radians. And then sine of 0 is going to be the y-coordinate from the unit circle, right? So my first point is 0 radians, and then sine of 0 is equal to 0. So we have 0, 0 as our first point. I don't like those whites. So give me a fun color. Purple. That's pretty fun. The next point is the angle measure is pi over 6. And the y-coordinate on the unit circle is 1/2. So again, you're seeing the points coming in over here as I'm plotting them. We have pi over 4, and then root 2 over 2 is 0.707, approximately. Then we have pi over 3, and square root 3 over 2 is 0.866, approximately. I have pi over 2 and 1. And I'm just going to kind of keep marching along the unit circle, plotting these points as I go. So what do you see happening here? Oops. Negative 1/2. And 5 pi over 4. Negative 707. 4 pi over 3. Negative 0.866. 3 pi over 2, negative 1. And we have 5 pi over 3, and that's negative 866. And then 7 pi over 4, that's negative 707. And then we have 11 pi over 6, and that's negative a half. And then we're back to 2 pi and then 0 again. So if I take a look at this, looks like the graph of sine looks like this, right? Everybody's okay with that so far? So if I kept going and I went around the unit circle again and did like 13 pi over 6 and like 9 pi over 4 and keep on going like 7 pi over 3 and kept going around another time, what's my next trip around going to look like? Thank you. Chick-lay. What's my next trip around going to look like? It's the exact same thing, right? It's just going to be further to the right, but it's going to do another one of these like up and downs. If I go around again after that, what's it going to do? Same thing, another one of these up and downs. So this is a function that its shape repeats over and over and over again as you go further to the left or further to the right. We call these periodic functions. So both sine and cosine are these periodic functions that repeat themselves over and over again. And when we have this wave shape like this, the general name for a function that has this kind of waving shape is called a sinusoid. All right, so let's put some stuff in here for us now, huh? All right, so let's do a big info drop here. So let's talk about the sine function in general. We just saw how to graph it, or what the graph of it was going to look like. So the sine function, the simplest version of it, its parent function version is just f of x equals sine x. Its domain is all real numbers. Remember, that's what we did in last chapter, right? We updated our definition for sine, cosine, and tangent, etc., so that we can do those operations on things that are not tied to right triangles, right? Instead of being stuck with angles between 0 and 90 degrees, we can now do sine, cosine, tangent, etc., for any sized angle we want, right? So sine, the domain is all real numbers. But if I look at the range, the lowest point has y-coordinate -1, and the tallest point has y-coordinate +1. Do you guys see that? Why am I using a bracket there instead of a parenthesis on the ones? It's because there's a point that has the y-coordinate -1, right? That y-coordinate of -1 is actually used by a point in the function, right? So the bracket means that that y value is included in this set. It's used. The parenthesis would mean you get right up next to it, but you don't actually get it. And the same thing happens at +1, right? There's a point like right here that uses the y-coordinate +1. That's why those get brackets as opposed to parentheses. Sine is an example of an odd function. Notice how like this part of the graph looks exactly like that part of the graph. How they're like catty corner across the origin. On like a diagonal. That was our definition for odd. or one way we could think about an odd function. Anyways, this function is continuous over its entire domain. So I can draw the whole graph with just one pencil stroke. I don't have to ever lift my pencil to draw the graph. And then this amplitude, midline, period. Let's talk about what these things are. I'm going to do that graphically first, and then we'll write in the verbal definitions of what these things are. But I think that it's just easier at first to do that graphically. So I'm going to just drop in this extra picture here just to draw or to talk about amplitude, midline, period, and frequency, for example. So I'm going to start with the midline. The midline is a horizontal line where it basically splits your graph in half. So half of the graph should be above the midline and half of the graph should be below the midline. Well, if I look at my picture, the x-axis is my midline, right? Everybody's cool with that? The amplitude is the distance from an extrema to the midline. And it doesn't matter whether you're going from min to max or minimum to the midline or maximum to the midline. It's the same distance either way because the midline divides it in half. Those are amplitudes, yep. Either one of them come out to be the same number. They're both amplitudes. The frequency, or the period, is the length of the shortest or the longest non-repeating segment. So let's say that we think about starting here at the origin. I do an up, and then I do a down, and I start at the origin. Then I start another up again, right? So that's like one cycle of my graph where I did a starting at the midline, I did an up, I did a down, and then I ended back at the midline. Everybody's okay with that? The distance horizontally from the start of that cycle to the end of that cycle, that's the period. So the period is like the length of one cycle of our graph. Everybody's okay with that? And then the frequency is basically how much of our period do we cover in one unit. So if I find like the number 1 on my number line, would be like around there. And it's saying that this part of the graph is like 1/2π of my graph. So it's like a little more than a sixth, or a little less than a sixth, I should say, of my graph that I covered in one unit on the x-axis. That's like my frequency there. So far, so good. I'm going to do the same info drop for cosine now, and then I'm going to write up the definitions for amplitude, midline, etc. So I'll get that all in here, all together in one place. So now that we've defined sine and cosine as like a function, right? These are now like sets of ordered pairs. I can apply the same ideas of parent function and resultant function that we talked about in 1.8. So if I do that, that'll allow me to think of every sine function as some transformation of its parent, and every cosine function as some transformation of its parent, and allow me to come up with rules for how to calculate the domain and the range and the period and the amplitude and the midline for all these, for any sine or cosine function, as well as a way to calculate or to compute points for the graph of some resultant function. Yes, certainly. Everybody cool with that plan? Okay, so let's do that now. So let's drop this in. So again, we say a function is a sinusoid if it can be written as f of x equals a times sine 1 over c times x minus h plus k, where a, c, h, and k are all real number constants, and a and c are not zero. So we can treat parent functions, or as parent functions, sine x and cosine x, and the functions a times sine 1 over c x minus h plus k and a cosine 1 over c x minus h plus k as resultant functions. And if we do that, we can say for any resultant function, I can compute the domain, range, amplitude, period, midline, frequency in the following way. So this stuff here is going to be our main tool that we're going to be using. You should memorize these, or at minimum, those should be things that go onto your note card, because we'll use those a lot. Okay, let's do an example where we're going to use these formulas here now. Okay? Am I going too fast? We're okay? Holler at me if I get going too fast. I'm trying to be careful and just kind of connecting these dots and adding in some narrative, but I know I'm doing all this screen grab and dropping, and I know that you guys can't write as fast as I'm dropping. All right. So let's do a couple of examples. So this example asks us to do a whole boatload of stuff, right? It says, given the parent function, f of x equals sine x, find the transformation for the resultant function. And then list the function's domain, range, amplitude, center line, period, and frequency. We're not going to do that for all these examples. But to do any of the things that are listed here, what am I going to need to do first? What do I need to know before I can start doing any of those things? The answer is I need to know the values for A, C, H, and K. Right? If I look at the formulas above, I need A, C, H, or K to plug into each of the formulas for domain and range and period and amplitude and midline and all that jazz. And I certainly need those values to describe the transformation. So let's start there. So the general form for the resultant for any sine function looks like this, right? That's listed up in that box that I said is you should have on your note card. You definitely need to know that. So if we look at our sine function, hopefully it's easy to see right away that the 4 or the negative 4 is our A, and the 1 is our K. Where we have to be careful, though, is the stuff inside the sine, right? So I need to make sure that I'm rewriting 2x so that it's going to be 1 over c times x minus h. Well, is there anything being added or subtracted to the 2x? No, right? So it should be easy to see that the h has to be 0 there. Everybody's okay with that? Now, how am I going to write the number 2 as a 1 over c? There you go. Yeah, that's exactly right. We talked about that last time. That the reciprocal of a reciprocal is like doing nothing at all. So if I want to do nothing to 2, if I write it as 1 over 1/2, that's doing the reciprocal to it twice. It's like doing nothing at all. And now I have easy to see that c has to be 1/2 and h has to be 0. So far, so good? Okay. Now, we talked about last time that skill of being able to pull out the values for A, C, H, and K is critical to everything we're going to do in this chapter. Almost everything we're going to do is going to be reliant on being able to consistently and effectively getting the values for A, C, H, and K from a formula or whatever, maybe from looking at a graph. We'll talk about how to do that later, or from like a situation, from some limited information. We'll talk about that later. But right now, first and foremost, you have to be able to look at an equation and find the values for A, C, H, and K from that equation. Okay? So that skill we just demonstrated there, we have to be able to do that consistently and effectively, or it's going to be big problems all chapter. This tends to kind of be an all or nothing chapter. If you have this skill, everything goes fine. If you struggle with this skill, you can make a big mess out of lots of stuff. All right, so let's describe the transformation then in words. So since C is positive, we have no reflection on the y-axis. Since the absolute value of C is less than 1, we have a horizontal shrink by a factor of 1/2. Since A is negative, we have a reflection across the x-axis. Since the absolute value of A is bigger than 1, we have a vertical stretch by a factor of 4. Since H equals 0, we know we have no horizontal shift. And since K is equal to 1, which is positive, we know we're going to be shifting up 1 unit. So how did I do that? Again, I used that set of criteria from last time that we said you definitely need to memorize, or at minimum needs to go onto your note card, right? All I did was use that same set of criteria from last time. I didn't want to write it again because we wrote it once already. But that doesn't go away here in chapter 3. We're going to use that frequently. Cool? Okay. Next up, it asked us to do the domain and the range and the amplitude. And it said center line. That's the same as midline. And then the period and the frequency. Well, the domain is easy. That's all real numbers, always. Again, if I go back and look, for any resultant function, the domain is all real numbers. Oh, swell. The range is going to be K minus the absolute value of A, comma K plus the absolute value of A. So the K in our problem was 1. And the A in our value was -4. So my range should be -3 to 5. Everybody's okay there? If I go back to that list, the amplitude is just the absolute value of A. So the absolute value of -4 is just 4. That's my amplitude. That's easy. The midline is y equals K. Well, K in our case was just 1. Now I want to point out to you guys, the midline is an equation of a line. It must start y equals. If you write down that the midline is 1 and not y equals 1, I will mark that wrong. Okay? The midline is not a number. It's not a measurement. It's an equation for a line. So it needs to start y equals. Everybody's okay? Okay? I just want to be clear, right? I'm sure you guys all appreciate that in terms of like, what is the standard? Let me be super clear right up front that if you don't do that, it's wrong. And you're like, what does it matter? It's an equation for a line. It has to have an independent, dependent variable situation going on. Anyways, the period is 2 pi times the absolute value of C. The C in our case is 1/2. So 2 times 1/2, or 2 pi times 1/2 is just pi. And the frequency is just always 1 over the period. So just 1 over pi. Feel okay doing this? Should be pretty easy, right? Once you pull the values for A, C, H, and K, it's just like plugging the stuff into a formula. And the formula is going to be on my note card. So like I can't screw it up to a great extent. It should be pretty easy, right? Okay. Yes, of course. Do we need to do another example of this, or do you guys think you got it? This should feel pretty easy, right? Okay. The other skill I want to talk about today then is graphing. So from last time, recall that we had, if we had some point in the parent function xy, and we transformed that into some resultant function, we can get that new point in the resultant function by doing cx plus h, comma, ay plus k. Again, we said last time that that should be a note card thing. You definitely want to have that on your note card beforehand. I'm going to just point it out again. Does it help me doing this for the note card? Maybe we can start writing our note card as we go rather than trying to get them in at the last minute for me. I'll try to do a better job of highlighting the things that I think are like really kind of need to be on there. Okay. So if we want to do the same thing with sine, cosine, tangent, etc., the question becomes, what point should I be using for my parent function? Right? So let's take sine, for example. So this was all the points that I used to graph one cycle. What did I use there? I used 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 points. That's too many. I don't want to do all 16 of these. Which ones are going to be the most important ones that I got to have to get the shape right? I'm going to need the x-intercepts. So here, here, here. And I'm going to need the extrema, the maximum and the minimum. That should be enough for me to get a good enough picture, right? Okay. Let's write that down. I had a hard time finding this. Oops, that's the wrong hour. This document last time, so I'm just going to steal it. I already have it in the other classes, so I'm just going to go drop it in here. So this sheet that says reference points is going to, I've listed the reference points that we're going to use for sine and for cosine, and then the other trig functions are down here also. We haven't talked about any of those yet for today. All we need to worry about is the ones for sine and cosine. Are these things you need to memorize? No, I would give these to you on a test. Okay, so let's do an example. Let's just say we want to graph let's say y equals -3 sine of 1/2 x. Nope, let's make it 2x minus pi over 8. No, pi over 2. And then plus 1. First thing I want to do is find the values for A, C, H, and K. Everything that I do revolves around these values. Almost every problem I'm doing this chapter, the first step is going to be coming up with these values. So again, the general resultant function for sine looks like this. Right away, I can see that my a should be -3 and my k should be 1. Everybody's okay with that? Now, the tricky part becomes getting the inside to look like that, right? I'm going to start by factoring off a greatest common factor of 2. When I do that, what does pi over 2 become when I factor off a 2? What? Nope. Because when I factoring off that 2, what operation am I really doing? I am dividing, right? What is 1/2 divided by 2? 1/4. So what is pi over 2 divided by 2? Pi over 4. Is that okay? No? Yes? Give me something. Somebody's alarm is going off. Beep, 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 beep. Beep, 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 beep. And I'm going to rewrite that 2 then as 1 over 1/2, just like we did before. So I can see that the c is 1/2, and the h, quite sneakily, is pi over 4. So far, so good? All right. So I'm going to go ahead and plug in my C, H, A, and K into my formula. So Cx plus H is 1/2 x plus pi over 4. AY plus K is -3y plus 1. I'm then going to take my reference points from the sheet that we just looked at a moment ago. So just as a reminder, I'm just getting those from the reference point sheet. So I'm going to go ahead and just plug these in now. So I have 1/2 times 0 plus pi over 4, comma, -3 times 0 plus 1. So that comes out to be pi over 4, comma, 1. And then I just keep on going. Oh no, Mr. Kulik. 1/2 times pi over 4 plus pi over 4. That's so many fractions. You guys can do it though. What's 1/2 times pi over 4? Not pi over 2, because when you multiply fractions, they just go straight across, right? Pi over 8. And if I want to add pi over 4 to that, what do I have to have? Common denominator. What would the common denominator? Okay, so would be 8. So I have pi over 8 plus 2 pi over 8, which gives me 3 pi over 8. Now, I'm perfectly comfortable doing that in my head. If you need to write things down, write things down. That's totally fine. And then I have negative 3 plus 1, that's negative 2. Can I also point out, too, that you can handle that fraction addition on your calculator if you just leave the pi's off? So if I do like 1/2 times 1, actually, let's do it this way. Let's do 1/2 times 1/4 plus 1/4. I have 3/8 and I just tack the pi back on. If you feel less than confident about your fraction arithmetic skills, use your calculator, right? Just take the pi's off and the calculator can handle the fraction, addition, and subtraction, multiplication, and then you just have to remember to put the pi back on when you're done. Everybody's okay? All right. Same idea here. So plugging in pi for x and 0 for y. So pi over, or 1/2 times pi is pi over 2. Pi over 2 plus pi over 4. What's 1/2 plus 1/4? Well, that's 3/4, right? So that's going to be 3 pi over 4. And then 1. If I take a look at this point, I see a pattern going on with the x-coordinates. I don't think I really even need to do the arithmetic anymore for the fractions. To go from pi over 4 to 3 pi over 8, I added 1/8, right? No. Oh my gosh, guys. Woo! Hold on a second. That number's not right. Why is that wrong? Look what I did. What did I plug in? What should I have plugged in? What a bonehead move that was. Ay, 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 guys. So that should be pi over 4 plus pi over 4. That should be pi over 2. Now if I look at my x-coordinates, now I see a pattern. Before I didn't. And I should have. What's happening? Just adding a 4th each time, right? You guys see that now? What should the next x be? Be 4 pi over 4, or just pi. And the one after that should be 5 pi over 4. And then 6 pi over 4, and 7. Yeah, etc. Yeah, exactly right. Everybody's okay with that? Now, you can continue doing the arithmetic like the way we've written it. That's totally cool. But when I notice that a pattern like that, I don't look a gift pattern in the mouth, right? It saves me a lot of grief in doing like these fraction operations. And if I don't have to deal with that, that's a good day. Because as much as I like fractions, and boy, do I like fractions, they're just kind of a hassle sometimes to deal with, right? And if I don't have to, that's always a little bit nicer. All right, so let's plot some points here. All right, so let's say, notice that each one of these are going up by a pi over 4. So each tick mark on my x-axis is going to be pi over 4. That's pi. That would be 2 pi. That would be like negative pi. And then my lowest I go is to negative 2, and the biggest I go is positive 4. So now I'm just going to start plotting my points. So pi over 4 and 1, pi over 2 and negative 2, and then 3 pi over 4 and 1, and then pi and 4, and then 5 pi over 4 and 1, so like there's one cycle of my graph, right? Everybody's okay here? What if I told that, what if the direction said to fill the space provided? What would I do? Well, I'm not going to generate more points. I could do that. Rather, what I'm going to do is just kind of look at the pattern. So here is my start. From my start, I then went over 1 and down 4. So I'm going to go over 1, down 4. Or 3, excuse me. And then from there, I went over 1 and up 3. So over 1, up 3. And then from there, I went over 1, up 3. So over 1, up 3. From there, I went over 1, down 3. So over 1, down 3. But actually, right here, I'm at the end of my graph, so I'm happy with that. You guys see what I'm doing? Just finishing the pattern. So here I should be going over 1, up 3, and then over 1, down 3, and then over 1, down 3, over 1, up 3, over 1, up 3. There, I filled the space provided. Everybody's okay with that? Again, on your test or whatever, I will ask you to fill the space provided. So if you don't do that, am I going to mark it wrong? Yes. Well, at least mark you down for it anyways. You get what I mean by when I say mark it wrong. Okay, that's it for today. That's the idea. So what I'd like for you to work on here is this chapter 3 worksheet 1 that I've placed in the content library. So the first page, we're asking you to just find the amplitude, midline, period, and frequency and list a transformation below. That's like the very first example I did today. Everybody's cool? The second example is asking you to do some graphing. Here I have a list or a place for AMPF. What does A stand for, do you think? Amplitude. The M? Midline. The P? Period. The F? Frequency. Okay? So when you do this, I want to see on your paper, I want to see the transformed points. So I will want to see like that stuff on your paper, like how you got it. Okay, so please include that work. But I have 4 graphs for you guys to work on of that. So that's what pages, hold on. Did I say 4? Maybe I meant 6. I think I meant 6. Okay, but you guys have the remainder of our time in class to get a jump on this. When would this be due? Next Sunday, not this Sunday, right? What's the only thing due this Sunday? That first worksheet 1. That is correct. Let me make sure that's representative or represented correctly in the grade book. Yes. Chapter 3, problem set 1. Edit. Chapter 3, worksheet 1 should not be on there. Adjust that one. You may.
We got glad. I did weird that you just
Oh,